Right, welcome back, grade 12s. And on the previous video, in the previous video, we basically looked at the effect of temperature on the equilibrium position. But with that one, we only focused on an exothermic reaction. So in this one, I just want us to go through the endothermic reaction. And the idea behind this thing is logically just the same. So say for example, okay, before we go any further, notice how with an endothermic reaction, I have the heat on the reactant side. Why? Because remember, with an endothermic reaction, heat is absorbed from the surroundings, right? So it needs to use that heat so as to then form into the products. So now let's say I introduce a disturbance, just a single disturbance here. Let's say now I increase the temperature. If I increase the temperature, we all know now that it will increase the heat. So as it increases the heat, what happens? Now notice something. I am increasing something that is on the reactant side. So what does the system do to reestablish equilibrium? It will need to decrease from the reactant side. And the only way to decrease the reactants is by using them up to form my product. And as a result, the forward reaction will be favored. Right? Why do we favor the forward reaction? Because we have increased the temperature, which increases the heat. And remember, according to Le Chatelier's principle, the system will reestablish its equilibrium by favoring the reaction that will counteract your disturbance. What was your disturbance? Increasing the heat. How do I oppose an increase? I need to decrease the heat. So the system will decrease the heat by favoring the forward reaction. Why? So as to use up the heat, use this up, and then form these. These will then increase. So the heat decreases, silver chloride decreases, and my products will both increase. Then they ask you in an exam, but they say to you, is the forward reaction exothermic or endothermic? We then need to come back to these things, ladies and gentlemen. Remember what we said. We said if you have an increase in the temperature, it favors the endothermic reaction. Therefore, what you've noticed here is that when you increase the temperature, you favor the forward reaction. Hence, as a result, the forward reaction is endothermic. Why? Let's go once again. We had said once we increase the temperature, we increase the heat. And as a result, to counteract that, the system must favor the forward reaction. But we had also said, like in the previous video, that an increase in temperature favors the endothermic reaction. And since we favored the forward reaction, this tells you that the forward reaction was then endothermic. And obviously, the opposite is true. That tells you that the reverse reaction is exothermic. Okay, but let's see how if that's true. So if when I decrease the temperature, what happens? When I decrease the temperature, that obviously means I need to decrease my heat. Okay, so when I decrease the heat, what happens? When I decrease the heat, things must change. So when I decrease the heat, what do you notice? I am decreasing on the reactant side. Therefore, the system will want to re-establish equilibrium by favoring the reaction that will counteract your disturbance. So when you decrease the temperature, that means you're decreasing the heat. The system will want to increase that heat. And in order to do that, I need to make more of the reactants because heat is on the reactant side. And as a result, I need to favor the reverse reaction. And there you have it, ladies and gentlemen. Now notice something. You have favored the reverse reaction. Then they ask you in the exam, is the reverse reaction endothermic or exothermic? You don't need to think too much. You go here. Remember, you must remember this thing. You don't have this in the exam. You just need to remember this. What did you say? We said that the decrease in temperature favors an exothermic reaction. And since in this case, the reaction that we favored was reverse, that tells you that the reverse reaction was exothermic. And that's what we said initially, remember. Right. So these are very important things that you must remember, ladies and gentlemen. I really hope that you are cool with everything that has happened here in terms of the effect of temperature. If you are not happy with all of that, then you should let me know in the comment section so that I know what to fix and where to do better. Remember, your comments make my heart warm and fuzzy. So the more comments you guys share with me, the more the better I become with this whole um information that I'm sharing. Right. So number two, we then look at concentration. Remember, if you're just asking why I'm only doing one example on temperature, just go to the previous video before this one. There's another example on temperature. So with concentration, we're focusing on aqueous substances and substances that are in gaseous phase. So now take a reaction between nitrogen gas as well as hydrogen gas, and that will form my ammonia. And then what do? I introduce a disturbance. What is that disturbance? Let's say I decrease the concentration of ammonia. Let's just take that disturbance. I decrease the concentration of ammonia. What happens as a result? So think about it. If I decrease the concentration of ammonia, what am I doing? I am decreasing on the product side. What does the system do to counteract that disturbance? The system will then increase on the product side. Why? You decrease on the product side, the system will want to increase on the product side. And as a result, the only way you can form more products, you need to use up your reactants. And as a result, from reactant to product, the forward reaction must be favored. Is this making sense? I hope this is making sense. I decrease the concentration of ammonia, which is a product. And as a result, for the system to counteract the disturbance, it must favor the side where you decreased or increased. In this case, I decreased the ammonia, the concentration of ammonia. And remember, ammonia is a product. So I decreased from the product side. The system will want to increase on the product side because it's doing the opposite of what you did. And as a result, if I want to form more of my products, I need to use up my reactants. And as a result, this guy will increase. These will then get used up. And that's why we say, in this case, the forward reaction is favored. Next example, for example, let's say now I'm going to increase the concentration of N2. Okay, let's just decrease the concentration. I'm going to decrease the concentration of nitrogen gas. What happens? Now remember, when I decrease the concentration of nitrogen gas, what effect will there be? Let's see. So nitrogen gas concentration, I decrease. So what do you notice? I decreased on the reactant side. I decreased on the reactant side. So what will the system do? The system will try to counteract my decrease. So instead of doing anything else, the system will then say, no. This person decreased N2. I will want to increase N2. This person decreased nitrogen gas. I'm going to increase nitrogen gas. That means I need to increase on my reactant side. And in order for me to add more of the reactants or to have more of the reactants, I need to use up my product. And as a result, from product to reactants, I favor the reverse reaction. And there we go. So since I decrease the concentration of nitrogen gas, the reverse reaction is favored. Right. Take a final example, ladies and gentlemen. Let's say now I let's say I add on, I increase the concentration of hydrogen gas. When I increase the concentration of hydrogen gas, what happens? Let's think about it. So if I increase the concentration of hydrogen gas, right, I am increasing on the reactant side. Therefore, the system will try to decrease on the reactant side. So if it wants to decrease from the reactant side, it needs to use up The reactants too. He must get used up. He must get used up. And when they get used up, they form my product. And as a result, if I need to move from reactants, use the reactants and form products, I need to move from reactants to products. Therefore, the forward reaction is favored. I really hope that was clear, guys. I really, really hope that was clear. I really hope that was making sense to people. It's very important, this one, very, very important. So I need to make sure that you guys understand what is going on here. Right, and then that brings us to the end of concentration. Then I want us to focus on pressure. Pressure. Now remember with pressure, it only affects products or substances in the gaseous phase. So assume I have a reaction of, again, N2 plus 3H2, once again, the Haber process, and this then gives me ammonia, which is a gas, a gas, a gas. So in an exam, if they give you substances that are not in gaseous form, like literally none of them are gases, then you shouldn't expect them to ask anything about, you shouldn't expect them to ask you anything relating to pressure, basically. Right, so now what happens? Notice something. When I increase the pressure, what happens? Remember in grade 4, you learned that pressure is inversely proportional to volume, right? That means the higher the pressure, the lower the volume. The lower the pressure, the higher the volume. So with pressure, an increase in pressure favors the side with the least number of volume or the least number of moles. But how do you check the number of moles? You need to add every stoichiometric coefficient of the reactants against the stoichiometric coefficient of the product. So I'm going to say that's 3 plus the 1 over there, that is 4 moles. And that 4 moles is against 2 moles of the product. So in which direction will my increasing pressure go? Will it go in the forward direction or the reverse direction? Let's think about it. Remember, when I increase pressure, I need to go to the direction with the lowest moles. Between 4 and 2, which one is high? Which one is low? The 2. Therefore, my pressure will go in the direction of the 2 moles. And as a result, it will go in the forward direction. Therefore, my increase in pressure will favor the forward reaction. However, now if I decide to decrease the pressure, the opposite is true. If I decrease the pressure, I favor the side with the highest. Remember, inversely proportional. If I decrease the pressure, that means I have low pressure. I need to favor the side with the high volume or high number of moles. So as a result, I will then go to the side with with the highest rather. I'll go to the side with the highest moles. And as a result, that is on the reactant side. Therefore, if I move from this side to the reactant side, I need to favor the reverse reaction. Right. Because I'm moving from products to reactants. Therefore, that will be my reverse reaction. And that is all there is to it, ladies and gentlemen. With pressure, this is all that you need to know. But I also want to add something because it can be a trick question in the exam. So I have a reaction between silver chloride and it decomposes into its respective reactant, that is your silver and your chlorine gas. Notice something. Remember, pressure only affects gases. Immediately, when you have any other phase of a substance, then pressure has no effect on that phase. Therefore, you need to go to the side with the highest moles in gas. So if I increase the temperature, if I increase the pressure, what happens? I need to favor the side with the lowest moles of gas. Now remember now, how do you know how many is on each side? Here you have one, here you have one. Do I use this one? No. Why? Because this silver chloride is in solid form. Therefore, the moles that you use are going to be 0 moles because it's not a gas, it's a solid. Similarly, with this silver here, instead of using 1, you use 0 moles. But with this chlorine, it is a gas. Therefore, you take that one as the 1 mole. Therefore, on the product side, you have 1 moles of gas. Therefore, if I increase the pressure, it needs to favor the side with the lowest amount in moles. So that's 0 and that's 1. Which side is the lowest? The left side, the reactant side. Therefore, if I go to my reactant side, I need to favor the reverse reaction. Aha. The reverse reaction. And there you have it. As a result, the reverse reaction is favored. Cool. And then what happens now if I decrease the pressure? Remember, decreasing pressure favors the side with the highest moles. And I hope you can see it now by now, ladies and gentlemen, that I have 1 which is greater than 0. Therefore, the system will then move in the forward direction, or the forward reaction rather. Therefore, when I decrease the pressure, I favor the forward reaction. And that is that to everything that we've done so far. This is all that you need to know with all these factors. If you can understand this part, then I promise you, ladies and gentlemen, the exam will be a breeze. But from me to you, I hope everything was well, and I will then see you in the next video. Please don't forget to like, comment, and share with your friends and your family and everyone. Do not gatekeep those results, guys. So please make sure that you comment as well, because like I said, your comments make my heart warm and fuzzy. So I need to know what you guys feel about everything that we do here. Therefore, your comments really mean a lot to me. But from me to you, I shall see you guys in the next video, and goodbye.